So this is a video breaking down the production of iron and steel. So when we look at the production of iron and steel, there's different stages that need to be looked at when we're doing this. Okay, so we have number one is mining, and in mining we have four different types of mining. Number two is ore concentration, and in this again, this is separating out the iron from the impurities. Here we have three separation techniques that we need to look at. And then we have making iron. From this, we have two types of furnaces that we can use. Making steel again, we have two different types of furnaces that are linked with the two previous furnaces. We have casting and forming. We have heat treatment, we have machine joining, and then we have the finished product. Okay, so when we go into mining, we have four different types of mining. So there's open cast, open pit, underground, and dredging. So the open cast essentially is taking off the topsoil and taking the iron ore out of the topsoil from the ground. The open pit then would be looking at the rock just under the topsoil. So any ore that is in the rock just below the topsoil, this is what open pit would be. Underground would be digging completely underground. Now the only one that's really different is dredging. Now this is taking the ore from the bed of a river or the under the water. Okay, so when we have the iron ore taken out of this, so when we're mining, we're looking for iron ore. When we have it taken out, it does not remove the ore. It does remove the ore from the ground, sorry, but we are left with clumps of impurities that we also don't want. So from here, as you can see in my diagram, we have the iron ore mixed in with impurities. We need to now remove these impurities from the iron ore. So we do that on the next step, which is ore concentration. Now, before we separate the iron ore, we need to crush the chunks of ore down into more manageable sizes. So you can see here, crushes the ore to more manageable sizes. Now, the first separation technique would be the gravity separation technique. So in the gravity separation technique, it obviously uses gravity to separate the iron from impurities. Now, it does this by using running water. And how it uses the running water is the iron ore is dropped down. We'll mark it here. The iron ore is dropped down into the running water, which then the path of the running water has loads of grooves on it. So as we can see here now, there's grooves that the running water will run through. Now the iron ore is a lot heavier than the impurities, so the iron ore will collect down here, and the water will just push the water will push the impurities along over the grooves that it has. So when we stop the running water, we are left with all the iron ore, the pure iron ore, at the bottom of the grooves. Now this bed also, the bed here also constantly vibrates to help the iron ore and the impurities separate. The next one is magnetic separation. So obviously this uses a magnet. To separate out the iron ore from the impurities. So here what is happening is that the iron ore, the crushed iron ore, is passed down over a magnet here. And what that magnet is doing then is that is attracting all the iron ore that is magnetic. So it's pulling all the iron ore towards the magnet, and it drops it into the a different bin. So here we'll have the ore bin or the ore container, and here is the waste. So the waste would not be magnetic and it would just fall straight through, whereas the iron is magnetic and will be pulled towards the magnet, hence separating it out. Okay, so the next one then is flotation separation. Now this one is a small bit tricky. So the main point here is to remember that this is used for metals that have a surface reaction to water. So metals that have a surface reaction to water. Sorry. Now the main step in this is that fine ore particles are mixed with water and oil. This then is pumped into the bottom of a tank. Air is blown in at the bottom of the tank, creating lots of small bubbles. The metal-rich ore particles stick to these air bubbles, and then they will be pushed to the top. The metal-rich particles then and the bubbles form a froth at the top of the tank, and then it is just skimmed off from the top, which the froth then will contain all the ore-rich particles, and the waste then is just pumped out from the bottom. So that's how this works here. So we will say here that the metal-rich particles stick to the air bubbles. These bubbles then go to the surface to create a froth. This is skimmed off. Now, so after this stage, the next is drying and pelleting. So concentrated ore that has been separated by the wet process, like gravity or flotation separation, needs to be dried as it's all wet at the minute. So what happens here now is it's just dried and clumped into larger sizes for transport. So it's dried and clumped into larger sizes for transport. So then we now have removed most of the impurities and are left with rich iron ore that can be easily transported. So here's my iron pellets, or the chunks of iron that we have removed. So we now need to create iron and steel from these pellets. Now how we do that is we use the furnaces. But before we need to use the furnace, we need to know about the metal extraction methods. So these are hydrometallurgy, electrometallurgy, and pyrometallurgy. So the first one, hydrometallurgy, is the concentrated ore is mixed with chemicals in a liquid solution. So this is mixed with chemicals in a liquid solution. Sorry. Chemical reaction occurs. separates the metal. Now this type of metals extraction works with copper, silver, gold, and platinum. And that is called hydrometallurgy. Now, the electrometallurgy, this is where electrodes are placed in a liquid solution containing concentrated ore. The metal is attracted out of the solution and deposits onto one of the electrodes. This is called electrolysis. So the electrodes are dipped into the solution. Electricity is passed through this and the metal is attracted to one of the electrodes. This process is called electrolysis. And the example here is aluminium. Now, the final one is called pyrometallurgy. This is heat. So the most common type of pyrometallurgy is smelting. So smelting produces the molten metal. So most common type is smelting. And it just produces molten metal. Now, the examples for these are iron, zinc, tin, and lead. Now, so once we have our, I'll go back up here. Once we have our iron and steel pellets, so it's our iron ore pellets, we then put them into the furnaces. Okay, so first we will go to the blast furnace. This does produce pig iron. Okay, so we take the iron ore, we put it into the blast furnace, and it produces out pig iron. So the important part of this is, I'll just highlight it here, seeing that it's here with me on the text. I'll zoom in here. So the charge is loaded through the top charging bells. The charging bells are a system of double doors that prevent the heat escaping. Air then, this is the point here, air is blasted through the tires to burn the coke. So the chemical reaction then takes place that causes the molten pig iron to sink to the bottom. The molten pig iron is tapped off from the tap hole. The limestone in the charge is used to collect impurities to make the slag or the waste, and the slag floats on the top of the molten pig iron. The slag is tapped off, and then the molten iron then will be tapped off from the tap hole. So then this will produce pig iron from iron ore. Now the next step then will take that pig iron and we'll put it into the cupola furnace. So this is our pig iron. And we put it in, and this cupola furnace creates cast iron, as we can see here. Again, I'll just zoom in here now. So this is used to make cast iron from pig iron. It's like a very small version of the blast furnace and operates on the same principle. So the burning coke melts the pig iron, and the chemical reaction happens and it removes more of the carbon in the pig iron, creating cast iron. Air is pumped through the tires again, exactly like the blast furnace. The powdered limestone in the charge again is used to collect impurities. The slag is tapped off at the slag hole. Molten cast iron is tapped off at the tap hole. So this would be used to make pig iron or cast iron. The next one makes steel. So we have the basic oxygen furnace and we have the electric arc furnace. So the basic oxygen furnace uses oxygen, obviously, to create the steel. So we have pig iron again, and it obviously turned it into steel. So the basic oxygen furnace makes steel from molten pig iron. It does this by blasting pure oxygen into the molten pig iron to burn off more carbon. So the fume hood, which is this section here, this is removed. The charge is poured in. Lime, the charge consists of molten pig iron, scrap iron or steel, and lime again. So lime again is there to collect impurities and make the slag. The fume hood then is pushed back down. Water cooled oxygen is pumped through the lance, which is lowered down into the furnace. The fume hood is removed. Now, this is the important part of this guy. The furnace is tilted, and the molten steel, is poured out of the tap hole. The furnace then is tilted back the other way, and the molten slag is poured out the opening. Okay, so this furnace will tilt either side. To get rid of the slag and to get rid of the molten steel inside it. So the last furnace then is the electric arc furnace. Now this makes new steel from scrap iron and steel again. So here we can see from this section, I'll write it down again, that the molten pig iron here is optional. So molten pig iron will be optional here. So what happens here is electrodes is used to create electric arcs, which creates a huge amount of heat to melt the metal and burn off the excess carbon. So the roof and carbon electrodes are lifted off the furnace. The scrap metal, the lime, and if you're using the molten pig iron, is put in. The lime again is used to collect impurities. The roof is put back on, and high voltage is applied to the electrodes to create electric arcs, which melts the metal and burns off any excess carbon. The roof then is removed again. The furnace is tilted, and the molten slag is poured out. And the furnace then is tilted forward for the molten steel to be poured out again, which is out of the tapping spout. Okay, so you can pause the video here to just look at the notes here that I have up on the screen that runs through each of the furnaces in detail again. So we're running the overview of production of iron and steel. So we go through to the ore being mined out, it's crushed and separated to form the concentrated iron ore. We go through the blast furnace, the cupola furnace, basic oxygen furnace, and the electric arc furnace. So we now have the specific metal made, be it steel or iron. We can now create different shapes and sizes of this material through casting and forming. So when we go into casting, there's two different types of casting. We have sand casting and we have die casting. So when we look at sand casting, it's obviously made it's using sand, but the applications of this would be suited to making more complex shapes than just rolling it out or drawing it or extrusion. So we'll just write that down here. For casting, it creates complex shapes from the material. Now for sand casting, it obviously uses sand. Now the difference between here is the sand casting is used for ferrous metals, such as cast iron and steel. This is because the steel and iron have a very high melting temperature and the metal molds would melt. So the die casting obviously is made of steel dies. So this is made of steel. So this would be used for non-ferrous metals. Now, The main difference here is the fact that the sand casting is used for ferrous metals, because if we use the ferrous metals for the die casting, it would melt the cast mold that we have made. So sand casting is used for high temperatures because sand doesn't melt. The sand bonds together using clay or chemicals, and when the metal has cooled, the mold is broken away. In die casting, die casting is used for non-ferrous metals like aluminium, zinc, copper, tin, because the steel dies will not melt. So what happens here is the dies are closed and the metal is injected in. The dies are separated to eject the item. So like I said, the examples here would be aluminium, zinc, yeah, copper, and tin. Oh, so that brings us on to the forming. So for the forming, there's different types of things different types of methods that can be used. So we have rolling, which is basically rollers compress the metal into make sheets. So compress metal to make sheets. We have extrusion. This pushes the metal through a die opening to create shapes with a uniform cross section. So pushes the metal through an opening or kind of design to create shapes on the metal itself. Then we have drawing. So drawing is similar to extrusion, but instead of pushing, it's pulled through the die opening. We next then have forging. So this is one of the important ones. Forging uses large compressive forces to deform a piece of metal into the desired shape. So there's different types of forging. There's open die forging, closed die forging, drop forging, hot forging. You can look at these in your book that you have with you. They're listed on page 42 of the Brighter Minds book. So you can just run through them yourself. So we here uses large compressive forces to deform the shape, to deform the piece of metal. We have thread rolling. It is basically using two rollers with grooves on them to turn the bar into a threaded pattern. So here it uses two rollers to force the thread pattern into the part. And lastly, we have stamping or pressing. This basically just stamps or presses a sheet metal into the pattern that you have. So forces the thin sheet metal over a metal die to create different shapes. So presses sheet metal into different shapes. Now, after forming, steel or iron can be heated to add and strengthen or give the objects give the metal different properties, i.e. to make it softer, harder, more ductile. So that's just, you need to know that as well. So that's that. There is a summary of the production of iron and steel. It runs through everything. So we have the mining, which we have talked about. We have ore concentration, making iron using the blast and cupola furnace, making steel using the basic oxygen furnace, the electric arc furnace. We went through casting and forming. We just went through heat treatment. Now, machining and joining. This is metals can be further produced. Sorry, metals products can be further shaped by machining. So this would be going to your practical rooms now in the practical labs for creating projects. For example, drill saws, lathe machines, milling machines, grinders. Metal products can also be joined via welding, adhesives, and mechanical fasteners, so nuts and bolts and rivets. So you go through this process yourself in the metalwork room or the engineering room when you're actually constructing your projects yourself. So that's the video there. Now you can pause and take down this summary there as well, which will help you. Thanks.